Michael Faraday's Candle Burned by Darcy Pattison. It was 3 p.m. on December 28th, 1848 in London, England. Horses whinnied, excited boys and girls stepped out of cars into the crowded one-way Albemarle Street and pushed into the Royal Institution. They were excited. This was the day that they would not talk about science, instead they would see science. Mr. Michael Faraday, director of the laboratory, would be giving the children's Christmas lecture. It cost 1 unit to attend. About 4,000 people crowded onto hard wooden benches. The 3-story auditorium was stacked so everyone in the audience could see the experiment desk. In previous years, some experiments turned fiery. People sat back, not too close. Mr. Faraday stepped up to the lecture table and began. I bring before you the chemical history of a candle. I must first tell you of what candles are made. The candle I have in my hand is a string candle, made of ox fat. Then here is a sperm candle which comes from the purified oil of the sperm whale. Here, also, are yellow and refined beeswax, from which candles are made. Here, too, is the curious substance called paraffin and some paraffin candles. The candle is solid, and how's that the solid can get up to the place where the flame is? This is a wonderful thing about a candle. You see that a beautiful cup is formed. As the air comes to the candle, it moves upward because of the heat of the flame, and so it cools the sides of the wax. The cup is formed by the air rising, which keeps the outside of the candle cool. I hope you will always remember that whenever a result happens, especially if it be new, you should say, what is the cause? Why does it occur? And you will in the course of time find out the reason. But how does the flame get hold of the fuel? There is a beautiful point about that. Capillary action. Capillary action, you say, well, never mind the name. It is by what is called capillary action that the fuel is carried to the part where the combustion or burning goes on. When you wash your hands, you take a towel to wipe off the water. Capillary action makes the towel become wet with water. In the same way, a candle's wick is made wet with the wax. The melted wax climbs the cotton wick to get to the top. Other wax particles follow because the wax particles are attracted to each other. As the wax particles reach the flame, they are gradually burned. The only reason why the candle does not burn all down the side of the wick is that the melted wax extinguishes or puts out the flame. Now, as to the shape of the flame, it is a bright oblong brighter at the top than toward the bottom, with the wick in the middle and certain darker parts toward the bottom. There is a current formed which draws the flame out. You may see this by taking a light candle and putting it in the sun so as to get its shadow thrown on a piece of paper. You see streaming upward the current of hot air, which draws out the flame, supplies it with air, and cools the sides of the cup of melted fuel. "It is too bad," said Mr. Faraday, "that we have not gotten further, but we must not keep you beyond your time.